Intel, from AMD, and from ARM. This announcement is really all about enabling a new class of hardware and new silicon partners for Windows to bring the widest possible range of form factors to the market. We made the announcement now in order to allow all of our partners to work together and build upon this innovation. Windows has always been and will continue to be about the breadth of hardware and software applications and innovation. We're very excited about the full set of partners for the next version of Windows. Nvidia, Qualcomm, and Texas Instruments are working on SoC designs based on the ARM architecture. Intel and AMD will continue to innovate on the x86 platform, including the new low-powered SoC systems that will be fully supported by Windows and will include support for native x86 applications. Windows support for SoCs is an important step for Microsoft and for the industry. Increasingly, customers expect the full range of capabilities from any device. The power and breadth of software that is available for today's laptop, the long battery life and always-on capabilities of a mobile phone, great browsing, productivity and media experiences, in addition to the basics, printing, and support for all of the hardware devices and peripherals. Windows has the breadth and depth and the flexibility to define and deliver this next generation of devices to customers through the innovation of our partners. Mike had a chance to show you some of the things that are shipping right away earlier. But what I'd like him to show you now is some of the work that we previewed earlier today in terms of Windows support for System on Chip. Please welcome Mike back.
So we announced earlier today the System on Chip architecture for the next major version of Windows. And what we did was a technology preview. So while everything out here today is based on Windows 7 and coming soon, what I'm showing you here is a first look at the platform support of the next major version of Windows. Now, we're not showing the new Windows user interface. We're not showing any new Windows features. This is all about platform support today so the partners can start working together on new designs. I'm going to start with an Intel system. And what you're looking at here is Intel's low-power Atom SoC system. Now, before I get started, I want to explain what we've got going on here. This is a kind of development board that we use to do pre-production software and pre-production hardware together. Underneath this heatsink is the actual chip. And the SoC is about this big. And by the time we actually ship, that entire chip fits on a motherboard about this big. So this is the entire motherboard of the PC with the memory, with the slots and everything. The PC doesn't need to be any bigger than this, plus a battery and a screen, and can be of any size. And what we're working on here is an example of what it looks like when we're doing development. Now, this is a future version of Windows. We're running on the low-power Atom SoC architecture from Intel, and what's so cool about this...
Future version of Windows.
Future version of Windows.
Current user interface.
Current user interface. This is all about supporting the basic chip level, kind of at the kernel level, if you will. The thing that makes the Intel platform really interesting is the compatibility with all of the existing software and hardware applications that run on Windows today. So what I'm showing you here is a version of Quicken that I just got from the store. Off the shelf, installed it, and it just worked. No modification. The same thing is true when I plug in this Windows 7 phone. You can plug in a camera, printer, anything that works on Windows works right out of the box here. And so a really high level of compatibility. You can see it recognizes the phone and it's going to start syncing. There it goes, it connected the device and recognized it. So all of that's working today. And that's one of the really big benefits of the Intel system. We've also announced today partnerships with 3 more partners that are making ARM-based systems. And I'm going to show you real Windows client running on ARM. So this is Qualcomm's ARM system called Snapdragon. And this is the Windows client running on ARM. I can pull up the command prompt and show you the version string for the kind of people that track that sort of thing. Just to show that it's real, I've got desktop pinning, I've got accessories launching. You can see I can open my photo library, I've got customization, I can change my desktop background. What I'm showing you here is the Windows desktop up and running live on an ARM system. And that's really the first time. This isn't virtualization. This is Windows running natively on ARM. We're also working with Texas Instruments. This is their ARM platform called OMAP. And what I'm going to show here is an example of how hardware and software applications can work. So I'm going to launch Word and paste in some text and hit print. And what I did there is actually launched Word. That's Word running on ARM. So this is a build of Word that we recompiled to be a native ARM application. And you saw it launch. You saw that I pasted in some text. And what I have down below me is an off-the-shelf printer from Epson. It's a USB printer. And what we did with them is we recompiled the ARM driver. We recompiled the print driver to run natively on ARM. And in just a moment, you can see that it prints. So that's real. Thank you. That's real Office working. That's real print driver working. And the print driver is just one of the subsystems that we have up and running. We can connect to cameras and storage devices and other cool things like that. Now, this third ARM system I want to show you is from Nvidia. And Nvidia is known for really high performance graphics. And the same is true on their ARM system as well. This is their Tegra platform. And what I'm going to launch here is PowerPoint. So I have another Office application that's launching. And it launches quickly. And you can see I can type into here Windows on ARM, and I can create new slides quickly, and the performance is fast. And that's because PowerPoint is one of the Office applications that takes advantage of hardware acceleration, so you can get smooth transitions between slides and smooth animations. It's running really fast because it's actually hardware accelerated today on the Tegra platform. I also can show you another application that's using hardware acceleration, a next version of IE. So here's Internet Explorer with an HTML5 demo, so you can see how smooth and responsive spinning these pictures around is, and you can see how quickly it responds to the mouse. This is all because the graphics is being processed on the GPU on the ARM chip itself. And performance is really important, especially for things like video. So I'm going to launch the Iron Man trailer, and I'm launching this in HD. This is full HD output, and what you're going to see is smooth, fast-playing video. It doesn't drop frames, it doesn't stutter, it's really high performance. This unit actually even has HDMI out, though it's not connected on this demo. I can jump around to a different frame in the movie and see how quickly it can catch up instantly. And it's playing fast and it's playing smooth. So what you've seen here today is Windows, real Windows, running Office, devices, high performance browsing, high performance video, all running on next generation of SoCs.
Super.
Thank you very much.
Thanks for all the help today, Mike, and thanks to all of our partners for the fantastic work that they're doing.
Thank you.
Pleasure. Great. This is an exciting time for our industry and for consumers. We have the opportunity, through the magic of software, to bring Windows forward, to redefine what is really possible. That's the power of this announcement today. Whatever device you use, now or in the future, Windows will be there. We've covered a lot of ground tonight. 2010 was an incredible year with over 1 billion consumers experiencing Xbox, Windows Phone, and Windows PCs, and much, much more. Xbox has transformed from solely a gaming device. It has become the place for